So in this talk, I'm going to talk about Haskell records, the past, how they've been before they are now, how they are now, and techniques how you can work with them, and future. So what's going to come in the future. I'm Simon, also known as Reactor Monk. I found that more people actually know me as Reactor Monk, so I put that out there firsthand. So Haskell records are like a common thing which people tend to complain about. So how many people actually started writing Haskell and ran into this in the first few? So yeah, everybody has a rough idea what approximately I'm talking about. So this is the main topic. But let's start out with the past. How are they? Why exactly are the records as they are right now? In the beginning, there was only data. There was no notion of record fields. Instead, you only had positional arguments. So it was basically a named tuple, more or less, nothing more. Then, with Haskell 1.3, which is 26 years ago, they added new types and the records we more or less know nowadays. So there hasn't been a whole lot of change over the time, only a few more language additions. But the base idea for the records is quite old now. And it was mostly implemented this way because they did not want to pick up a system that would be too complicated because they didn't really know which one was the best one. So they picked a rather basic one, which is what we know nowadays. So a very short GHC detour, just to explain how things work roughly under the hood so you understand the further slides a little bit better. There's a thing called a reader name, which is basically when the GHC parses your code, it's what it sees first. So if you have just a head in there for list head from prelude, that's initially getting parsed as a reader name. You can have them unqualified or qualified. Unqualified if just head, or qualified, for example, for t.pack. You might have seen that quite a bit with import data text qualified as t, so you can use them qualified. And then later, that unqualified name gets resolved into a qualified name, which has all the association. It comes from this module. It's defined over there, and then getting passed on to the type checker. And additionally, there's a thing called a field label, which is specifically used for duplicate record fields. And there it's simply a string for looking things up. It's not actually a proper name. So to explain why I'm actually mentioning those is basically all the past proposal to fix the record situation. All of them have quite long names. But you could say that most of them are rather similar in the changes to GHC itself. So they will all work relatively similarly in the end. And you could say they're basically, the underlying concept is basically type-directed name resolution. So you have the idea of namespacing, which is, I think, what Octa does more or less. Or you resolve things by name. So the idea here is that usually, if you have a reader name, there is a unique name associated that the compiler can resolve. Otherwise, you get an error from the compiler that tells you duplicate name, and it doesn't know which one to pick. So the idea here is for, let's go back a tiny bit to the namespacing, which is basically the idea is that you import things as you and use explicit namespacing to pick your correct selector because it doesn't, so you tell the compiler. I've also seen people actually use that in practice quite well so far. The proposal would basically be to add a little bit more namespacing, that you can actually have local namespacing and not only module namespacing. But yeah, let's get back to the type-directed naming resolution. Yeah, it has a little bit of a dot with additional syntax, but the gist of it is that basically the compiler takes your reader name and figures out which name underneath it should actually pick. So it has multiple, what you usually would get a compiler error because it does not know which one to pick. It now knows which name to pick based on the type. So it basically picks the only name which works and picks that one based on the surrounding types. This is basically how type-directed name resolution is supposed to work, and that's why it's named like that, because it takes the surrounding types and based on that it picks the implementation, which is kind of similar to type classes but different, because if type classes you have only one name, which is the one of the type class, and then you have instance search. Here it's different because you have different implementations, different names, and you try to find the right one. So another idea is to actually use type class resolution for finding the right thing. And here you have the first, the first one is the record itself. Then you have a field which is any kind of proxy, which stands for the field you want to access. In this case, it is a proxy. It could also be a type level string, which a proposal will use that I'm just going to explain. And then the T is whatever the field type is. Then you have an instance with it, which allows you to use get and set. There's the idea of the simple overloaded record fields, which uses the type level strings. So this is, it uses type level strings to actually access things, which is more or less what we have nowadays, where you pass in a string and you get a getter or setter back. So, summary. A type checker needs a resolved name. So you need some way to give the type checker a name so it can run the Hidley-Miller algorithm and give you back a type check program. So you need some way to actually figure out from the source code which name do you actually mean from the EST which it produces out. And there's various ways how you can go from the field label, which is mostly just a string, to an actual name and dig that out. Yeah. So this is more or less how the different proposals were like. So now let's see how it actually looks like right now. So there's different ways you can actually work with records nowadays. There's the old school method, which is basically you just use what you have already. There's duplicate record fields, which is what came out of those proposals, which I explained about the type-directed names resolution. And there is the idea of using lenses for working with records, which can be either generated with template Haskell or you can go via generic lens. But if you don't know generic lens yet, it's awesome. So how would old school look like? You prefix all your field names. It works. It has good type inference. It compiles fast. But you have quite verbose code. And for example, if you're working with ISON or database fields, you actually have to remove the prefix each time. So you have more work. You need to make sure that you actually don't change your prefix length, etc., etc. But hey, it's fast. Good inference. Okay, duplicate record fields. Here, you don't need those prefixes anymore because the compiler is fine with you actually having more than one field of the same name. So, hand up, who thinks this compiles? Sorry to disappoint. So yes, nice try. So the main issue here is that duplicate record fields, yes, there is a way, basically the type checker or the reader sees you have the ID in the print statement, and it tries to find out which name you're actually referencing, so which record you actually want to pull the ID from, because it needs the correct name. Now the issue here is that the type-directed naming resolution nowadays is not really type-directed. It's more like somewhat type-directed because it runs before the type checker, which makes the whole thing semi to almost unusable for using the actual selectors. Because it can not use the inference to actually figure out which name you use. It can only use the very close context. So if you were to add a type annotation to the U here, it would compile. But that's not very ergonomic. So the other way you can actually also do this is with Haskell, which more or less does what you want. With using getField type applications, and you just say you want to actually pass the whole thing as a type level string. Yeah, it works. It's it's semi-ergonomic. It works quite well, and you can build something on top of it if you want to. And just a little thing on the side. Currently, this getField is on a hasField type class, which is a magic type class which gets resolved by GHC when you compile things. You can actually also implement your own instances for it, which works just fine in case you want to have some virtual fields, etc., etc. However, setField is currently not supported yet, but there's a proposal on the way and it's getting implemented at some point in the future. So the proposal has been accepted, it's currently getting implemented. Another thing which I've just learned about yesterday, you can use a GHC plugin and use dot notation. So what this one does is whenever you have a dot notation without spaces around it, it basically takes it and converts it to the get field, which you saw beforehand. And it also has there's a hasField library which implements the set field as well. So this one also actually works with setters just fine. So this almost gives you the same thing, but remember that basically here you always have to have a space between dots, or at least of one hand side of the dot if you use this plugin, because otherwise it will rewrite your source code if you use function composition. For example, if you like to use lenses and like not to have spaces between dots and lenses, it will trip you up. But, I mean, let me think. I think I saw the changes were like 3 months ago, so it's fairly new. And yeah, it has to be, I don't know when GHC added the plugins API, but it can't be older than that.
This doesn't throw a compiler here?
No, this works. I don't have it here, but I have the example. I tried it and it works. There's template Haskell lenses with make fields, which generates your lenses because, well, you like lens soup. And you don't even need duplicate record fields here because it works with prefixes, and then you can use the good old lens stuff, and this works almost all of the time. So I ran into this at work, so I had to find a solution. So this is basically, you have 2 modules which define your data types, and they do not import each other. And whenever you run make fields, it creates a class which has a field ID. Now, the template Haskell actually checks, is there already a class which has the field ID, which matches what it would generate and does not generate it. However, if that one does not know about that class because they're not importing each other, then it will generate its own class, and will blow up again. Because now you have two classes with the field ID, which makes the whole thing useless again. So, yeah, sad.
So could you go back to the slide really quickly? The data constructor takes like book with book ID with a string, but then you, like the definition of book or user, you take a string, but then you pass an ID.
Oops. Yeah. Yeah, it should be ID field. I'm sorry. I copy-paste mistake.
Well, the idea of having to resort to lenses to solve this problem just blows my mind as something so esoteric and brought in to fix something so fundamentally basic. What I would like to see, and I don't know enough about Haskell because that's not my native language, but some things like Boolean should scope globally because true and false are so pervasive. There's something to the domain where you say, I want this to scope globally, and then if you don't say that you want to scope globally, I would like it to be scoped on a private basis.
I'll get back to that because I think it's a bit longer. I'll get back to that at the end of the talk if that's fine with you. So yeah, you get the same error again because you have two IDs. So the next thing I thought about is, there's this nice little thing called generic lenses, which you can use like get field. It's just field, it uses generics, and it makes lenses for you. So this works pretty nicely, but you have the whole field thingy. It's a bit more annoying, so I figured, okay, let's write some template Haskell, which generates that for me. It's about 10 lines, I think it's about 7 lines of template Haskell. It's fairly straightforward. I put that in our code, in our production code. It works. I just have a huge list of fields. So you basically have your C declaration file where you just declare all the fields. Yeah. Then I asked Jongor, that's the author of generic lens. And then he was like, what? Just use labels. So you can actually use labels as lenses if you have the correct import, which is data generics labels from generic lens, and then you can use any kind of labels. So this is basically, in my opinion, a somewhat decent way how you can work with this without, if you don't want to prefix things, etc., etc. And for us, it worked decently well. Now, another thing which is kind of very, very useful concept is the idea of extensible records, which is basically the next step. We now have a somewhat working solution to accessing fields in a somewhat generic manner. However, there is no way as of yet to actually have records which you don't have to declare beforehand, which are very useful if you are modifying, for example, JSON. Like at work, for example, we have a JSON coming in with about 20 fields, and then you need to modify a few of those fields with intermediate data constructs, maybe, and then you just get huge data declarations, which is somewhat unwieldy. So, yeah. So what exactly is the idea of an extensible record? This is PureScript, where we have that idea, and the idea is that it's basically not nominal typing anymore, but actually structural typing. So those are actually the same type. Those are simply type aliases. So you could replace a user with a user2 without any issues, and it would be exactly the same. With Haskell, if you have two things with exactly the same fields, they are different. So why would you actually want extensible records? This is an example from simple JSON, a JSON library for PureScript. And he basically makes the point you are parsing JSON, but you have one field which is incorrectly named. So in your JSON, it's actually called grape, but you want to read it into the field cherry because that's what you need to send forward. So how you usually do that in Haskell is there's basically the issue where you could auto-generate it, but as soon as you need to modify one field, you need to write everything manually. So basically to do one change, you need to write everything out, which is quite annoying. So what this allows you to do is you can rename one single field instead of having to change the whole thing. So this basically infers the type which needs to read because of the record renaming, infers the type which it needs to read from the JSON, reads that, and then renames it to the type you actually want. So you can have something like that in Haskell with a bunch of different libraries for extensible records. Yeah, I mean, that kind of worked, but they all have their limitations. There is actually a huge Google sheet which basically says on how complicated they are to the compiler. And they all have their downsides. Some of them don't go beyond 8 fields because it's such a work on the simplifier where it's basically the compile time scale based on, I think it's ON square or some fun things like that. So yes, they exist. I don't have any more examples for those, but most of them have their limitations of one sort or another. So they're not really too nice to actually work with. So yeah, let's go to the future of things that don't exist yet, but could happen at some point. So the one thing which I'm currently working on is the idea of no top-level field selectors. As you remember, with generic lens, you basically access things via name. However, if you declare a record, you always get those top-level field selectors with it. So you basically additionally, if you have an ID, you additionally generate an ID. And because there's also an ID in preload, they will clash as soon as you try to use one of them. So you're basically putting garbage into your namespace that you don't need with duplicate record fields, because usually those selectors are not very useful. So the idea is, if you enable the language extension, it doesn't generate that name anymore. Which is, if you use duplicate record fields, because the selectors usually are not useful, frees up a bit of namespace. You don't have to do the funny underscores anymore, which people tend to use, or at least we use them, and you can reuse those names just fine. So the idea is that this would compile because there is no more name in scope as a selector name. So the next big thing is this one here. I don't know how many have you heard of row types just yet. However, there is currently a GHC proposal to implement row types. It's no small thing, but they already exist in PureScript. That's where the row to list comes from. It's basically how you work with row types. So why would you want them in the first place? So for example, you can just merge records without having to do anything else. This is, for example, useful. We're converting from one data format to another, which has at least like 20 fields here, 20 fields here. You can actually then write partial, you can output. You don't have to have one huge function which generates the whole thing, but you can actually have smaller function which all output parts of the record, and then you can merge it together. You can do patterns like that with merging just fine. You can rename fields on the go, which is also very useful if you want to change a name because your legacy format has a slightly different name in there. Or you can have partial records. Also, another part is usually if you have, there's a reader T design pattern, which basically says only require, you basically pass around your configuration via reader T, and you should only require the fields which you're actually using, and you can do that with lenses just fine. But why use lenses when you don't need to? So you can basically say, I have a function here which is only interested in the port, and then that function can only read the port, and you can pass in more fields than that, but the function itself will only have access to port. So how do row types work? So first you have a row type, and then you have a you have a type record, which takes the row type and produces you an actual record, which you can put values into. So you can then use, this one is a closed record, so you cannot attach any fields anymore. But if this were open, you can then attach more fields and pass it to actual record and do things with it. So how can they also work? You can actually construct open sums with them, not just records, open records. So there's quite a few applications for them. For example, typed errors. You can do checked exceptions of some sort. If you want to know more about this, there's Google Matt Parsons on typed errors. He has a blog post which explains how exactly you get there. And he works with lenses in the end. But you can get by without lenses if you have row types, and it's also a bit faster. Another thing you can do with it is JSON decoding, as already mentioned. And the JSON decoder for pure script using row types is like 300 lines of code. It's just a decoder. The parser comes from the underlying JavaScript. So yeah. So how do you actually work with row types? Like, yes, they're there, but how do you actually write functions which use them? It's a bit more complicated. But I could get into this, but the very rough idea is that they work similar to how H-list iterations work. And there's plenty of tutorials, or some tutorials on that in Scala, for example. But how I work with them is basically I take simple JSON, I copy-paste the code which does the iteration for me, and I adjust it as I need it to. So how could this look like in Haskell? Similar, with a bit less parameters, because you actually have type families in Haskell, so you don't need to do as many things in there. And yeah, take this with a grain of salt. I asked Jan Brücke, the guy who's currently implementing GHC, the row types in GHC, and said this could approximately look like this. If you already want to experiment with row types a little bit, there is actually a implementation as a plugin, Coxswain. I haven't worked with it too much, however. It's just a thing out there. I'm not sure if it has been worked on too much. But yeah. And the whole thing is basically currently being implemented. To be honest, I'd expect it probably be maybe a half a year or a year. Things like that take time, even if you're a full-time student. So yeah, this is basically what I wanted to talk about. I'm from Saarland, and this is basically my 1-minute sellout. We are currently in Europe, rather big. We have about 2K engineers, and we have everything in terms of domains. We sell clothing. We have quite a bit of data flying around, and I would also like to thank Dejan for gathering me a bunch of material, and Justin for all the PureScript stuff. Yep, that's my talk for now. And I already see the questions coming.
So in the end, you implemented, not the very last thing, but the row types initially in PureScript, or like right there, yeah, this stuff. It looks really similar to the library I playing around with maybe all.
Well, yeah, I mean, the duplicate record fields will work if you specify the type. Duplicate record fields will work if you specify the type of the thing you're trying to access. So that will work just fine. But yeah, the main issue why you actually have the problem in the first place is because there's only one namespace in Haskell, and that's the global one. Like there's no sub-namespacing because you don't have objects. Like that's a big benefit of having objects is, yeah, you have some namespaces per object. So you have a longer history of Haskell than I do. And yeah, I've also seen like so many of the proposals, they're rather similar, and they just look a little bit different on the syntactic side. And it's probably the bike shedding you're referring to. So, more questions?
With prototypes, do you get the same kind of compiler guarantees that you would with like a regular record?
Yes.
Okay, so thinking like, it's like if I parse some JSON, I guess the parser has to enforce the existence of types or of rows, I guess, of fields that I'm using later. Is that how it works?
Yes. So it's basically, the dot syntax is a specific magic for basically saying that here I want to access a field of that row. And it's basically because how the row works. If you have a row, you can basically say, look me up a row with this field, and then you have the type based on that. And this works somewhat O1 style, theoretically, because rows are unordered. So a row does not actually have an order in it by itself, officially, most of the time. It's a bit more interesting because you can actually have duplicate rows. In that case, you kind of have some order, but you cannot have duplicate fields. But yes, you have all the compile time guarantees.
Now, I understand why we're talking about this. Is that, a certain amount of it is inherent in what we've built in the language, and so it makes sense that we're doing that. But my question is, why should I feel at all confident about the new proposal, considering I joined some of these perspectives, and yeah, why should I care that this is actually going to get anywhere further than what we have? Because I personally feel like some of this is just untenable. And mostly what Brendan was saying back there is that this is a simple problem, we're just not working together. And so how is this new proposal going to change any of that? Or should we care about the new proposal because it will significantly improve our lives? And it didn't seem to.
Well, it's currently not done yet, but the basic idea is I switched over from Haskell to PureScript. And that's why I'm basically saying that if this works in a similar way in Haskell than it does in PureScript, then yes, it will help quite a bit if it's actually done. However, there's naturally a few more interesting problems with it in Haskell than is in PureScript. Because in PureScript you have JavaScript objects, and that's more or less a one-to-one mapping from row types to whatever you have down there. Naturally, the thing is with data types, you can do quite a bit of optimizations. Like with the current records, you can do quite a bit of optimization. However you implement records based on row types, it always depends. For example, if you use a small array or something a bit more compact instead of a map, you should get some similar speed. So that's basically one of the implementation things. But yeah, one of the questions is how well will it actually work? But the current implementation is to actually not implement anything record specific, but only implement the row types, and then people can build their own records on top.
Well, one nice thing performance-wise is because it's all the compile time, you don't need to
Yeah, I don't actually know how well that stuff actually works. Like one of the things, for example, is how do you do with open rows? If you have a closed row, it's rather easy to say, you have an array, and this is element 1, element 2, element 3. This is name, ID, and age. But if you have an open row, you basically have to pass along the ID for each index because you don't know exactly where to access fields. Yes, you do know at compile time, but it's more like if you have one module and you cannot do global optimization, so you actually have to pass along the index of the fields to access. I'm not entirely sure if I answered your questions correctly, though. So yeah, I'm not entirely sure how the time looks like, but I think we have time for more questions if there are any.
Is the change also difficult just trying to do it in a way that would break? If you made changes to records that would break like temple Haskell lens, like the way it uses the record access. So many libraries that now currently there's some cost.
So one of the things is that the implementation, like the proposal for row types, does actually not implement any new syntax for records or anything. It only implements the row types themselves and maybe a tiny bit of syntax to specify the row type, but not the record. So the difference between the row type and the record is, let me see if I have the right slide here. Here. So the top one is a row type, which specifies which field are there. And then you have a record which takes a row type and makes it into an actual record you can pack things into. So the proposal here is only to actually implement the first part, which is the row types, which can help you implement records based on that. But the syntax for the records themselves is not to be changed, according to the proposal. So the hard part is basically just implementing the compiler itself, not the actual breakage or anything. So the idea is it should not break anything.
And I want to note that this is a common, you can do this with the roadmap collaboration I mentioned. Like you can basically write this exact same thing. It's like a little bit more syntactically verbose, maybe like 15%, a little bit more characters, but this is code you can write. Unfortunately, it's just not part of the compiler itself, it's not being built in. And the compiler not going to build itself because they have to do like a lot of type of machinery that's not implicit in the way.
What's the name of the library?
Some road types, and it's a form of C type.
Target. So some of the targets.
The syntax is
But yeah, you can.
The initial data row documentation, that page is not very good documentation.
You can scroll down to see examples of it. There's some examples in the GitHub repo. It's literally C example, such example of LHS.
Oh, here. So yeah, it looks fairly similar. I don't know.
Origin, you can see that for recovery, where you just have like the unary record with x equals 0, and the unary record y equals 0, and then that dot plus is the merge, that's the entire type. The record, and it tracks the other type, it tracks the relationship between the record fields x and its underlying type. Yeah, there's open sums as well. That's implemented in the cycle.
I'm using Decoding to merge exception errors.
Kind of build like an ad hoc some type of error.
I could also spend the last 10 minutes to talk a bit more like what you can actually do with row types, if you'd be interested in that. So naturally no slides, but the biggest thing is basically records, which you can mutate. The variance is also basically you can do checked exceptions. You've seen the blog post by Matt, which that I mentioned how you can actually do this in Haskell more or less with lenses, and you can then discharge. But the nicest part is basically about checked exceptions is that they are useful when you can actually discharge like one or two of those exceptions, and then say I've handled them. For example, that could be that in our case, because we write web services all the time, is you actually return a 404 because you didn't find something. It's not available in the database.
I think you look at checked exceptions.
Yes, that's what I'm talking about. Yes. Yeah. You're meaning I should pull it up. Got it. So yeah, this is basically, you can then write your own little, you have 3 different errors, and then you can simply add those together. And then you can basically collect all those errors. And you can also have handlers for those errors specifically. Yes, with inject. And I wrote a tiny bit addition where you can actually throw records directly, so you don't have to do all the inject proxy stuff, just a little bit of syntax. Yeah, you can basically, here you can handle errors, and you have a record of error handlers, which is pretty sweet, and short syntax, and you get actually acceptable compiler errors with it. No funny lenses or anything. And then yeah, you basically have handle error and all of the records here. And to actually use it, you can then throwing to actually inject stuff is a bit more verbose. I'm not entirely sure if the pull request has been accepted or not to actually being able to throw records. Record syntax. So this is basically one way. What else can you do with it? For example, there's the interpreters, like free. You always have a little bit of the fun idea of how do you implement interpreters, for example, for database access and one for talking to another service. And then at some point you want to merge those because your application uses those, and those. So you need some sort of open sum type. And with this stuff here, this is extremely trivial because you can simply merge those variants here. You can just put them together and say, now I use this, and this. And then you can also actually execute some of those effects into something else just fine because you have good compiler support, which allows you to say, here I want to handle those 3 cases, and you can just give it a record of an implementation of how exactly those things should work. So you have basically straightforward implementations for all of the patterns which you could use. We actually don't use it at work, but you could use this. This is in PureScript run. Another thing which you also find as a common pattern in Haskell is the reader T pattern, as opposed to MTL. You can also implement some sort of MTL with this naturally. It's a bit different, a bit less nice. But with the reader T, where the basic idea is your whole thing is basically reader T IO, and then maybe an accept T, but people actually recommend not using that anymore. But there you also have the thing is that you somehow want to be able to only access parts of your configuration or whatever. And how do you do that? You have open records. You just say this thing only needs those 3 configuration values. No lenses, no nothing required, and you can just use records. This is basically the few use cases I've seen so far, and it's basically you have most of the patterns which you use in Haskell to do any kind of dependency injection or write larger applications. Basically, you can just map more or less one-to-one on top of row types, and your machinery gets way less complicated. No more lenses, no more constraints, and you're basically good to go with most of the patterns which are recommended to being used nowadays. Any questions about that? I mean, it's what the old school version is. That's the old school version. It's basically old school, where you just use prefixes. You can use prefixes, which are kind of similar to just using type annotations. So yeah, that works. Or if you use generic accessors anyway, it also works. So yeah. But yeah, F# now also got anonymous records recently, so have fun with those. Okay. Thank you for your time.